So in this video, we're going to look at how we can model velocity, displacement, force, and acceleration using vectors. So each of these measurements include a magnitude and a direction, and we'll talk about what that magnitude and direction mean for each of these, okay? So we'll begin with velocity. So velocity is the rate of change of displacement with respect to time. Velocity can be modeled as a vector where the speed is the magnitude and the direction is the angle. So if we look at 3i plus 4j, we can start at any point. Let's start here. So we're going to go across 3 in the I direction. So 1, 2, 3. And we can see that the I direction is in this direction there, 1 unit. And then 4 in the j direction. And the j direction is perpendicular to the I. And again, it's 1 unit. So we're going to go 1, 2, 3, and 4. So our velocity vector starts from here and goes in that direction. Now, this velocity vector can go from any position. So it can go from there, it can go from anywhere. But wherever it goes is always 3 in the I and 4 in the j. So now the speed of this velocity vector is the magnitude of this vector here. And we can work out its magnitude using Pythagoras' theorem. Because we have 3 on the horizontal and then 4 going vertically up, where this is a right angle. So we have 4. So the magnitude of the velocity vector is equal to the speed. And using Pythagoras' theorem, this will be the square root of 3 squared plus 4 squared. So the square root of 25. And this works out as 5 meters per second. So this is the speed of this velocity vector. Okay, so now the direction. Now we're asked to work out the direction with respect to the unit vector I. So what we're looking at is this angle here, which we'll call theta. Now we can work out theta using trigonometry, where we have the tan of the angle theta, or the tangent of the angle theta, is the opposite, so 4 divided by the adjacent 3. And if we take the arctan of both sides, theta will be the arctan of 4 over 3. And this works out as 53.1 degrees to the nearest decimal place. Okay, so let's move on to looking at displacement vectors. So we know that displacement is an object's distance from a point measured as a straight line. So displacement can be modeled as a vector where the distance is a magnitude and the direction is the angle. So again, if we're going to model 2i plus 3j now, so we'll start here, 2 in the I direction, 3 in the j. This will be our displacement vector. And we'll label this using a column vector, 2 and 3. So again, this displacement vector can be true at any point. Okay? It works at any point going 2 across in the I and 3 in the j. So the magnitude of this, the magnitude of a displacement, is going to be given as the distance. And you can work out the magnitude, again, using Pythagoras, where it's 2 in the I, or 2 horizontal, and 3 vertical, and here's your right angle. So the square root of 2 squared plus 3 squared, which is root 13 meters. And to work out the angle of a direction with respect to the unit vector I, we can draw in I here, and we're going to look at this angle theta. So theta will be the arctan of the opposite 3 over the adjacent 2. So theta works out as 56 degrees. Okay, so let's have a look at force and acceleration vectors. So forces are also vectors as they have both a magnitude and a direction, where the magnitude of a force is how much force is being exerted on an object, and the angle specifies the direction of a force. So do you want to try and work out the magnitude of this force vector? You can pause the video, and when you come back, we'll go through the work solution. Okay, so welcome back if you had a go. So we'll start by labeling a point. We're going 1 in the I and then 2 in the negative j. So here, this is our force vector. We'll label this as 1 and minus 2. So the magnitude will be a base of 1, a height of 2. So the square root of 1 squared plus 2 squared, which is root 5 newtons. So finally, in example 4, state the magnitude of the acceleration vector. An acceleration is the rate of change of velocity, where the magnitude of a vector is the magnitude of the acceleration, and again, direction is given by the angle. So do you want to try and work out the magnitude of this acceleration vector? You can pause the video, and when you come back, we'll go through the work solution. So we'll start at 1 point, we'll go 2 in the negative I, and then 3 up. So we'll have this as our acceleration vector, minus 2 and 3. So a magnitude will be the square root of 2 squared plus 3 squared, which is root 13 meters per second, or meters per second squared. Okay, so thank you very much for watching, and I hope you found that useful. You can download the full lesson and worksheet from my website. There's a link in the description below. Thanks again, and take care.